All right, now we're moving on to our second type of sequence that we look at in this course, and that's geometric sequences. So notice in this case the commonality. I hope that you see in each case we multiply by a constant. So in this case we call it geometric, and we can see the definition here, each term obtained from the previous by multiplying. So we're geometric if and only if the ratio of a term and its previous term is constant. And we call this our common ratio, which I have written here, so I guess I don't need to write it again. I'll just make my arrow a little bit longer. So R is my common ratio. Why do we call it geometric? Well, the definition of a geometric mean, as you might guess, is to take a bunch of numbers, multiply them, and then however many numbers are, you take the nth root. So if we have two numbers, let's say A and C, and I take the root of them, then the solution to that is the geometric mean, which is B. And in our case, we can see that if I have a sequence A, B, C that is geometric, then I know that B is A times R and C is B times R. Well, that means that if I manipulate this, I could say that R is B over A, so C would be equal to B squared A, which then means that R is B over A, B squared over A. That makes more sense. B squared over A. Therefore, AC is equal to B squared. That means that root AC is B. And again, if I have two numbers, multiply them and square root them, I call that a geometric mean. Because I can take these two numbers, multiply them and square root them and get B, we call this a geometric sequence. Again, this formula is sometimes handy for solving. So if I have a geometric sequence, then the geometric mean of A and C make B.